Welcome back, and in this lesson I want to talk about network address translation known as NAT. NAT's used within home networks, business networks and cloud environments such as AWS. If you have a thorough understanding of NAT and how it works, it will make using any type of networking, including AWS, so much easier. Now I want to keep this video as brief and efficient as possible, so let's jump in and take a look at exactly what NAT is and how it works. So NAT's a process which is designed to address the growing shortage of IP version 4 addresses. IP version 4 addresses are either publicly routable or they fall within the private address space of IP version 4. Publicly routable addresses are assigned by a central agency and regional agencies, which in turn assign them to ISPs, and these ISPs allocate them to business or consumer end users. And IP version 4 publicly routable addresses have to be unique in order to function correctly. Private addresses, such as those in the 10.0.0.0 range, can be used in multiple places but can't be routed over the internet, and so to give internet access to private devices we need to use network address translation. In addition to this, NAT also provides some additional security benefits which I'll be covering soon. Now there are actually multiple types of NAT which I'm going to cover, and all of them they translate private IP addresses into public IP addresses so that packets can flow over the public internet and then translate back in reverse so that internet-based hosts can communicate back with these private services. So that's the high-level function of NAT, but each type of NAT handles this process differently. First, we've got static NAT, which is where you have a network of private IP version 4 addresses and can allocate a public IP version 4 address to individual private IP addresses. So the static NAT device translates from one specific private address to one specific public address, in effect giving that private address access to the public internet in both directions. And this is how the internet gateway within AWS works, which I'll be covering in another video. Static NAT is what you would use when certain specific private IP addresses need access to the internet using a public IP and where these IPs need to be consistent. Dynamic NAT is similar, but there isn't this static allocation. Instead, you have a pool of public IP addresses to use, and these are allocated as needed, so when private IP addresses attempt to use the internet for something. This method of NAT is generally used when you have a large number of private IP addresses and want them all to have internet access via public IPs, but when you have less public IP addresses than private IP addresses, and you want to be efficient with how they're used. Then lastly, we have port address translation, and this is where many private addresses are translated onto a single public address. This is likely what your home internet router does. You might have many devices, so laptops, computers, tablets, phones, and all of those will use port address translation, also known as overloading, to use a single public IP address. Now this method, as the name suggests, uses ports to help identify individual devices, and I'll cover in detail how this method works later in this video. This is actually the method that the NAT gateway or NAT instances use within AWS. So if you do have any AWS experience, then you'll recognize this process when I'm talking about the NAT gateway and NAT instances in a separate video. Now, NAT as a process only makes sense for IP version 4. Since IP version 6 adds so many more addresses, we don't need any form of private addressing, and as such, we don't need translation. So try and remember this one. IP version 6 generally means you don't need any form of network address translation. Okay, so now I want to step through each of the different methods graphically so you can understand how they work. And I'm going to be starting with static network address translation, or static NAT. To illustrate this, we're going to use a visual example, so let's start with a router and NAT gateway in the middle and a private network on the left and then a public network on the right. We have a situation where we have two devices in the private network, a server and a laptop, and both of these need access to external services, and let's use the example of Netflix and the CAT API. So the devices on the left, they are private, and this means they have addresses in the IP version 4 private address space. In this case, 10.0.0.10 for the server toward the top and 10.0.0.42 for the laptop toward the bottom. Now this means that for these two devices, packets that they generate cannot be routed over the public internet because they only have private addressing. Now the CAT API and Netflix both have public IP addresses. In the case of the CAT API, this is 1.3.3.7. So the problem we have with this architecture is that the private addresses can't be routed over the public internet because they're private only. The public addresses of the public internet-based services can't directly communicate with these private addresses because public and private addresses can't communicate over the public internet. What we need is to translate the private addresses that these devices have on the left to public IP addresses which can communicate with the services on the right and vice versa. Now with static NAT, the router or NAT device maintains what's known as a NAT table. And in the case of static network address translation, the NAT table stores a one-to-one device mapping between private IP and public IP. So any private device which is enabled will have a dedicated, allocated public IP version 4 address. Now the private device won't have the public IP address configured on it, it's just an allocation. So let's say that the laptop on the bottom left wants to communicate with Netflix. Well, to do so, it generates a packet as normal. The source IP of the packet is the laptop's private IP address, and the destination IP of the packet is one of Netflix's IPs. And let's say for this example, we get this using DNS. Now the router in the middle is the default gateway for any destinations, so any IP packets which are destined for anything but the local network are sent to this router. Let's assume that we've allocated a public IP address to this laptop of 52.95.36.67. So there's an entry in the NAT table containing 10.0.0.42, which is the private address, and 52.95.36.67, which is the public address, and these are statically mapped to one another. In this case, as the packet passes through the NAT device, the source address of the packet is translated from the private address to the applicable public address, and this results in this new packet. So this new packet still has Netflix as the destination, but now it has a valid public IP address as the source. So because we've allocated this bottom laptop a public IP address, as the packet moves through the NAT device translates the source IP address of this packet from the private laptop's IP address to the allocated public address. So this is an example of static NAT, and for anyone who's interested in AWS, this is the process which is performed by the Internet Gateway, so one-to-one static network address translation. Now this process works in a similar way in both directions. So let's say that the API client, so the server on the top left, wants to communicate with the CAT API. Well, the same process is followed. It generates a packet with the destination IP address of the CAT API and it sends it. As it's passing through the NAT device, the router replaces or translates the source address from the private IP address to the allocated public address, in this case 52.95.36.68. The CAT API, once it receives the packet, sees the source as this public IP, so when it responds with data, its packet has its IP address as the source and the previous public IP address as the destination, the one which is allocated to the server on the top left. So it sends this packet back to this public IP, and remember, this public IP is allocated by the NAT device in the middle to the private device at the top left, the API client. So when this packet arrives at the NAT device, the NAT table is checked, it sees the allocation is for the server on the top left, and so this time for incoming traffic, the destination IP address is updated to the corresponding private IP address, and then the packet is forwarded through to the private server. This is how static NAT works. Public IPs are allocated to private IPs. For outgoing traffic, the source IP address is translated from the private address to the corresponding public address, and for incoming traffic, the destination IP address is translated from the allocated public address through to the corresponding private IP address. Now, at no point are the private devices configured with a public IP. They always have private IP addresses. And just to reiterate, this is how the AWS Internet Gateway works, which you'll either already know about or will learn about in a different video. So this is static NAT. Now let's move on to dynamic NAT. Okay, so this is the end of part 1 of this lesson. It was getting a little bit on the long side, and so I wanted to add a break. It's an opportunity just to take a rest or grab a coffee. Part 2 will be continuing immediately from the end of part 1. So go ahead, complete the video, and when you're ready, join me in part 2.